3 questions. Which are the following check with thermal imaging cameras? So thermal imaging camera you put in front of especially switchboards or any electrical equipment, and will bring up an image with all the hot spots shown. So what could you use it for? Check a switchboard for loose terminations, definitely. Check it overheated motor bearings, definitely, and check for overloaded cables. So it's used for all of those, all the above. What were the consequences connecting a meter and ammeter in parallel with a load? Okay, so ammeters have to be connected in series. If you put in parallel, you're going to use the meter to short out the load. All the current will go through the meter, and you'll probably blow the fuse in the meter. So let's have a look. So it's not that one, not that one, this one here. Likely blow the fuse in the meter. So I should use a clip-on. Clip-on's the way to go. Why are insulation tests carried out a higher voltage than the equipment? Because 230 is, so what we've got to do is 230 volts is a RMS, so the peak's 325, so we kind of double the RMS. So here it is here. Sure, the equipment is tested above the peak value. Nothing to do with lightning, nothing to do with that, and nothing to do with that. Okay, so C. Description outlines proof, test, prove. We've done that heaps, so you can go through that. Proved on a known live supply, known isolated. No, it's going to be live, so it's not D, it's not B, so it's either C or A. I'd say it's going to be A. Test is carried out. Test equipment is fully proved again, but it still works on another isolator, so on a known. Okay, this one here, A. Known live supply. Which of the following best choice? Underground cable. Underground cable, you're going to use a neutral screen. The neutral will protect the cable if it's dug up or anything. It's a more robust cable. So neutral, you could use TPS, but you'd have to put in some conduit or something to protect it. So neutral screen cable we can bury direct. Conduit wire, you'd have to put it in some pipes or something. And speaker cable, you'd have to protect it once again. So you're not going to achieve any of these. Neutral screen cable we can direct bury. Cross-sectional area cable is increased and other factors are kept constant. Let's have a look. So we've got a cable here, and we get the exact same cable, but we make it heaps bigger. So we've increased the cross-sectional area. It's a lot thicker. So what can we do with that? We can get more current down it. Okay, there's a higher current carrying capacity. Ambient temperature surrounding the cable rises. So if the temperature goes up, option tab, delete. If the temperature increases, what happens to our resistance? Does our resistance increase or decrease? Our resistance goes up, which is a bad thing. So as our cables and stuff get hotter, our resistance goes up, we can carry less current. So what does it want to know here? What happens to the current carrying capacity of the cable? It will decrease. That one there. Our resistance goes up, we can get less current down it. What is the colour of the neutral in a single phase flexible colour? Single phase flexible cord, light blue. That one there. Speed at 4 pole AC generator is increased. If we increase the speed, we're going to be getting that out of our generator. If we increase the speed, it will do this. So what's increased? The frequency, the hertz. What will happen to the frequency? It will increase. Okay. Which of the following best describes an MEN switchboard? Not necessarily that, because we can have distribution boards as well, so it's not that one. Equipment for controlling or for controlling protectors, circuits, no. Connection to an earth electrode via an earthing conductor and between earth and neutral. It's got to be this one, eh? Memorable link. That's our MEN board. It's not that one. No connection. There is a connection. Yeah, so C. each RCD protector subcircuit and switch will have its neutral connected to. So our subcircuits come back, they don't go directly to the neutral because they're going through the RCD. Each RCD will have its own little neutral bar. So here it is here. What must be provided? Overload protect circuits per one or more socket outlets in domestic installation. Okay, so we need an RCD there, and it's got to be rated at 30 milliamps. This one here for residential. In order to achieve fast fault clearance times, we must ensure that. So fast faults, we want all our protection to operate really quickly. How do we make sure our protection operates quickly? We make sure we have massive fault currents or big fault currents. To have big fault currents, we need low earth fault loop impedance. So one of these will say low. This one here, sure. Earth fault loop impedance is low to ensure high fault current. That sounds like the one. Earth fault is low, it's possible to ensure low fault current. No, we want this one here. We want high fault current. High fault current, fast operation. RCBO is a combination of a RCD and a miniature circuit breaker. Where's that one there? Right there. Why do we test proof when testing? Make sure the circuit is live. No, we want to make sure it's isolated. To make sure our meter is reading quickly, to make sure we get the same result when testing the proof and the test. Why do we test proof when testing? To prolong the battery of our meter. It's a hard question to understand. Let's cross out things it isn't, and then we'll have another look at it. Nothing to do with the battery and meter. We want to make sure it's isolated, not live. Why do we test proof when testing? Make sure our meter is reading correctly, to make sure we get the same result when testing the proof and the test circuit. No, we don't want the same result. We just want to make sure. Because it may be isolated, we may get no results. So it's got to be this one here. Make sure our meter is reading correctly. When testing a toaster, what is the lowest acceptable? Okay, so portable appliance testing, insulation test is 1 mega ohm unless it's an MIMS element, which is 10 kilo ohms. But a toaster doesn't have MIMS in it, so it is 1 mega ohm. That one there. It's the lowest we can have. Ammeters should be connected in series, not parallel, not series parallel. Otherwise, we're going to put a short across the load and we're going to blow it up. Should equipment be tested for resistance? Should equipment be tested be left energized while carrying out? Okay, so when we're doing resistance testing, ohm meter, using a resistance tester, we've got to make sure that it's isolated. So should equipment be testing be left energized? No. Only if it's low voltage at all times. So the answer is no, right there. Should it be energized? No. If your meter doesn't have auto range, okay, so what do? You always start at the top and you work your way down. So where's that one there? Start somewhere in the middle, start at the top. Here it is here. Start at the top, go work your way down. What should help identify the fault has a chord? Prove, test, prove. Prove, test, prove. That one there. Prove, test, prove. Neutral connection, Edison screw fitting should always be connected. So Edison screw one, that's the one with our thread in there. Our light fitting. And inside it's got the thread, not the bayonet one. It's the threaded one. And if we look inside, it'll have a contact there in the middle, and it'll have a contact on the side, which is a piece of steel. We've got to make sure that this one here is the live and the outside one is the neutral, because your finger can touch that sometimes if you're taking the lamp out. Okay, so what's it say? The neutral connection. Okay, so it's got to go to the threaded bit. Right there. Easy. What class of appliance? 2 squares? Class 2. Done that heaps. Class 2. 2-pole induction motor. What speed? Speed is going to be draw that. You get your frequency times 60, and you divide it by pairs of poles. Okay, pairs of poles. Nothing to do with the voltage, nothing to do with the power. Pairs of poles. Hard to write with the mouse. Okay, F times 60 pairs of poles. 50 frequency times 60 seconds in a minute. So this is going to be 3000, and it's got 2 poles, so that's 1 pair. So it's going to be 3000 divided by 1, which equals 3000. Colour of a neutral conductor, single phase flexible quarters. I think we had that before, light blue. Required to install supply cable on a portal. What factors we need to consider when correct cable for this? So you're going to put a concrete mixer. What factors you need to consider when selecting the correct cable? The length is definitely going to affect it. So it's mechanical protection, definitely. Number of cores, yes. So all of the above. D, all of the above. Let's stop it right there.